Welcome to the 1953 Nobel Prize in Physics, which went to Frits Zernike, not to be confused with Frits Zwicky, who was the guy who had the first suggestion of dark matter and was a physicist that used to get into huge fights with people, including everybody from Admiral Nimitz to Albert Einstein. But that's a story for another video. Frits Zernike won the prize for his demonstration of the phase contrast method, and especially for his invention of the phase contrast microscope. Now, that's a lot of technical stuff in one space, right? You might have heard all those words before, but not necessarily used together. So let's look at them a little bit together. Now, what is contrast? Normally, contrast is thought of being something that's different. It's like we could say things like, it's cold today in contrast to what it was like last week. It was very hot. It's very different. When it comes to light and photo processing, photo editing, we think of contrast as the difference between the image we're trying to see and the background. So we want that contrast to be huge so that image kind of pops out. Well, remember, he's doing this work in the 40s and 50s. Now we would just say, hey, give me Photoshop. I can fix it. Boom, problem solved. Push a couple buttons, bingo, bango, there's your image. Well, it wasn't really possible there because, first off, we didn't have personal computers. They were doing this stuff with film or by looking through a microscope and sketching out images. It was a much different world. So he had to find a way to make it so that you could actually see certain things without going to great lengths to alter your sample. Now, what does all that mean? Well, let's dive in and take a look. So what he did was he came up with a new kind of microscope, and I've drawn a little sketch for it. Please forgive the crude sketch. That was me making it, so you know it's a little wonky, especially when I do it by hand. But light, you have to have light when you run a microscope because you have to pass light through your sample. Otherwise, you can't really see anything. It comes out pretty dark. So he had a light like everybody else does. He runs his light through what's called a condenser lens. That condenser lens, its whole purpose in life is to focus light from the big broad source into that sample where you want it to be so you can get it as bright as possible. The objective lens, then after the light goes through that sample, takes it and sort of spreads it back out so we can focus it back to the lens so you can actually see it properly rather than having it come across all a little bit jumbled. Otherwise, you'd be completely out of focus without the objective lens. So before we get the light, though, before we see it in the eyepiece, what he does is he passes it through a phase shifter to separate it from the background. So he shifts the light by about 90 degrees, and I'll explain that more in a second. And what that does is it allows you to use different properties of light to bring the background out. Now, when you phase shift something by about 90 degrees, what you do is you alter where peaks and troughs are from the light wave as it goes through, and that allows you to get that better image. So the better image is brought about when you bring all the light back together and the waves are either strengthened or canceled out due to that phase shift, and the image you want to see just pops right out of the background. Now, how much does it pop out of the background? Now, before this time, and even in some science labs today, you have to go through great lengths to prepare your sample to be seen. So, you know, if you're putting things under an optical microscope, at the time, you would have had to take very small samples. You would have had to kill whatever it was in, take a small sample of tissue, put it on the microscope, dye it with different dyes, and then eventually you could kind of see it pop out. But the two pictures you see here are mouse kidneys. And what you see in one is non phase shifted, and then what you see in the other one is obviously phase shifted, and you can really see those two pop out. And what this does, this allows you to look at things that are still alive, right? You can actually take neurons and put them on a sample and actually look at them while they're still functionally alive as they do die. But it gives biologists a chance to study things a little more carefully in ways that you couldn't have done before that. And it actually lets you see a lot of definition inside things you couldn't have seen before. And that helps everybody learn more about what they've got under the microscope, which is a very good thing. It's not a bad thing for a guy who grew up with the son of two school teachers and where his specialty was actually mathematical physics, because in the modern world, you never let theorists in the lab because they usually destroy stuff. I'm just kidding, my theorist friends. I love you guys. You know it. But he turned out to be pretty good at hardware design, and that worked out really well. His work after he won the prize actually went on to look at condenser theory, which is a big deal in quantum mechanics. So he wasn't done with this. He actually went on to do other things that are actually still relevant today. So thank you for tuning in. Please don't forget to hit like and subscribe. That does help us out with the algorithms, and we will see you on the 1954 video, which is coming soon.